This video is just going to quickly review the rules for how to balance redox reactions. There are a number of step-by-step examples that I have also posted. After you take a look at this, why don't you go check those out? So let's begin with how to balance an acid. This always has to be done first. Here's the list of the 6 rules, but I'm going to go through these kind of one by one and give you some tips and tricks. So to start with, you always want to begin by assigning oxidation numbers and identifying the half reactions. You need to be careful because an element may show up more than once on each side, and you may notice that the oxidation number changes for one of those appearances but not for the other. Each half reaction that you write should only include the species that contain the element that is undergoing reduction or oxidation. For example, if your oxidation reaction features a carbon species going from, say, carbon 0 to carbon 4+, then you want to include each species in the equation that contains carbon in order to balance correctly. And note that there should be one reduction and one oxidation half reaction. This is because they're linked. The electrons produced by the oxidation process are absorbed by the reduction process. You can't have 2 oxidations or 2 reductions happening at the same time. The second step is to balance each half reaction separately, and we're going to use the same algorithm for both. You start by balancing everything that's not oxygen or hydrogen, and you just use your normal chemical equation balancing skills for that. Next, you want to balance the oxygen by adding water, H2O, to the deficient side. So this tells us why we have to balance oxygen first. We always bring some hydrogen with us. Now you can balance the hydrogen by adding H+ to the deficient side. We add H+ because we're balancing in acidic solution, which contains H+. Our last step is to balance the charge by adding electrons to the same side as the H+. We add those electrons because their negative charge can cancel out the positive charge, and you want to make sure that you're adding enough electrons that your reactant side and your product side have the same overall charge. Next, once you've got those balanced half reactions, you're going to balance the electrons in and out with coefficients. The hint here is to find the lowest common multiple of the electrons in your coefficients. And if you've done this correctly, you should have electrons coming out as products in your oxidation half reaction and electrons going in as reactants in your reduction. So let's take a look at a quick example. Copper 0 goes to copper 2+ plus 2 electrons, and iron 3+ plus 3 electrons becomes iron 0. What you want to do is multiply the oxidation by 3 and the reduction by 2 to get 6 electrons in and 6 electrons out. This way, when you go to the next step, the electrons will cancel out entirely. So you add together the half reactions and you cross out anything that appears on both sides. Now make sure that, if you've got 4 waters on one side and 2 on the other, that you still leave 2 excess waters on one side. But you just want to make sure that everything that is on both sides cancels out. You then rewrite it cleanly, adding in your indicators of state. If you want a review on how to handle indicators of state, check out the word problem strategies video. And then do your final check. You want to check not just that each element is balanced, you also want to check that the charge on both sides is equal. If that's good, then you're all set. If you were supposed to balance an acid, your work is done. But if you need to balance in base, this equation, balanced in acid, is where you start. So to balance in base, the first thing you want to do is add OH- to both sides to balance H+. So for example, if you had 2H+ in your products, you would add 2 OH- to the reactants and the products to balance it. Any OH- and H+ that are on the same side get squished into water molecules, H2O. Eliminate water that appear on both sides of your equation. Then rewrite it nicely, put in your indicators of state, and do your final check. And the reason why we work with hydroxide, OH- in this, is because hydroxide is what makes aqueous solutions basic. So there's your little overview of the rules with my tips and tricks. Go check out some of those step-by-step examples. Otherwise, I'll see you in class or in my office hours.